right, this is the pre-talk announcement, which is that we have a lot of material and we're going to fly through it. So I just wanted to say if we're speaking really fast, it's because we have a lot of cool things to talk about. Oh, are we actually in the talk now? I was going to give you like the preface to the talk. Are we in the talk? Is that a thing? Okay. All right, we're here. That's fine. We'll dive in. It's going to be fast. If you've seen our other talk, well, one, I'm Christina Lee. I work at Pinterest.
Sorry, and I'm Quintet Now, and I work at Trello.
Okay, so that's us. If you've seen our other talk, we kept the same name, but this talk is not related at all, completely different talk. So if you came here to see that one, I apologize in advance. I'm really sorry. But this one's great too. And just to give you a little outline of what this talk is, we're going to start at a really fundamental level of Kotlin, going through type system and generics. And then when Huyen takes over, we're going to move on to some more practical stuff that'll affect you in your day-to-day life that builds off of those concepts. And so with that preface, we'll jump right into the type system. Now, this is not my computer, so as you can tell, everything's different. This is a visual representation of the Kotlin type system, courtesy of our friends at JetBrains. Thank you, Svetlana, used with permission. Now, the interesting thing here is you can see down in the lower left-hand corner, that's your like traditional type hierarchy, where you have things like children and parents and their subtypes of each other, and that's all fine and dandy. And then when you look at the top right, you see this shadow hierarchy, which is all of the nullable versions of that. Now, two things to note is that nothing is the subtype of all types. It's all the way down at the bottom, everything springs from it. And any question mark up in the top right is the supertype of all types. Everything is a subtype of that. So with that, and I should point out too, you can see that int here is a subtype of any, so that's kind of cool if you're used to the world where primitives are different from references. And now back to the action. Okay, so just wanted to give you that visual model so when we dive into this code, it'll make sense. And with that, I'm going to give you one more caveat about subtypes, because I think we talk about super and subtypes a lot, but we don't necessarily define them, and sometimes we use them in a really wishy-washy way. So a type A is a subtype of B if A can be used anywhere that B can be used. To put that into concrete terms, you would say a cat is a subtype of animal because anytime you ask me for an animal, if you return a cat to me, that's perfectly valid and I will be very happy. Be slightly happier if you return a dog, but you know, a cat will do. So it's fine. And so also another caveat is that we often use type and class interchangeably, but that's not really accurate. If it was, we probably wouldn't have two words for it, so that should be the first clue. And here's a case why. So in that first line, you see that I'm assigning a string to a variable with the type string, and in this case, string is the class, and string is also the type, so that's fine. We can use them interchangeably there. But that falls apart as soon as you have nullability, because here, string is still the class, but the type is now string question mark. And then, of course, this gets even crazier when you go into any sort of collection. So all three of these examples, their class type is list, but their types are list int, list string question mark, list of a pair of an int of a list of a string, etc. You can get almost infinite types out of any given class. And so to use them interchangeably is not really accurate, and you'll see why that matters soon. Now, you might be thinking, okay, types are boring, you're probably the only person in the world who likes them, and you're probably right about that, I do love types, but they give us some things that you really care about as developers. For one, if you've heard anything about Kotlin, I'm sure you've heard about null safety, like it's the only thing we like to talk about. We've been talking about it for 4 years, it's great. And I think sometimes people think there's like some magic around null safety that JetBrains folks did to get us this, but really it's just an extension of the type system. So for the same reason you can take an integer and put it in a field of number, you cannot put in something that's nullable into a field that's typed as string. And that's just because string question mark, it is not a subtype of string. A string can be used anywhere a string question mark can, but not in reverse. And so this is just a type system feature that you cannot assign something that's more generic to something that's less generic. It's the same reason that if you switch this to be int and this to be a long or something, it wouldn't work. So that's cool. We get some of our favorite things just from having a good type system. Now, to talk about some of the other features there, nothing being one of them, you probably are less familiar with nothing than the other stuff because we don't really talk about it that much. But nothing is a pretty simple concept. It's a cool one, but it's simple, and it means this code will never complete. Like, no matter what happens, all I can tell you is this code just won't complete. And if you look at the type signature of to-do, you'll see that it just returns nothing, and its implementation is to throw an error. So it is holding up that contract of, yes, it's returning nothing, but the code will never complete. And that's why something like this, where you have a complicated type signature that you maybe don't want to mock, which would normally say, hey, you need to return something, if you use to-do, it doesn't complain. It compiles. And again, the reason for that is because nothing type signifies that the code will never run successfully. It's never going to complete. And so you'll see the same reason we can do logic like this, where we have that question mark, colon, and then we throw something, but otherwise we're assigning to string. It applies here too. Here, I have the nothing type, which is the correct return type, but you're going to see that it says it's unreachable code. And that's because, again, if something returns nothing, it's guaranteeing that it never completes normally. And so this assignment here, it's never going to be reached, which I think is a really cool way to understand nothing, that even this assignment will not be reached. Okay, diving into any versus object. Now, we use them interchangeably, but once again, there's nuance there. So just to start off, if you declare a class and you don't give it an explicit supertype, like any is what you're going to get. So these two are equivalent statements, the default there. And like I mentioned before, there's this primitive niceness where actually what Kotlin is doing under the hood is very similar to Java, but you don't have to deal with that, so you can just use them interchangeably. Something that you would call like a primitive in Kotlin, a pseudo primitive, can still boil up to an any. Now, more interesting is how any differs from object. And so any differs because it only has 3 declared functions on it, a toString, a hash code, and an equals. It doesn't really do anything that great. It's kind of the basics. But you'll know that object has more methods than that. And if you do want to get the object out of any, which is what it is at runtime, you can cast it, but Kotlin's going to immediately complain and tell you probably shouldn't do that. So you can, because that's the type, but you really, really shouldn't. And it's worth noting that any and any question mark, they're different things. I think that we have this concept of object as like the end-all, be-all, and everything can be an object. But any and any question mark, you can't assign them interchangeably because, again, they're different types. One is a nullable type and one isn't, and everything that applies to other nullable types applies here. Okay, my favorite topic, the last one I'm going to reel off, is unit. I love talking about this because unit and void are kind of things that we ignore a lot. And I've included my favorite quote on the topic here, and the essence of it is that void and unit are basically the same thing, and their use is to tell you that a function is called only for its side effects, which is cool. But the difference is that when you're using void, you're trying to say that a function returns nothing. Seems okay. When you use unit, you're saying that it returns nothing useful. And I know that seems vague and unclear, but if we take a look at how you can use unit, it'll become more, concrete, which is to say that unit can be used as a value that you assign somewhere. It can be used as a type. It is indeed the default return type if you don't include anything. This is, in essence, returning unit. And if you go in and click into unit, the definition, you can see why this is the case. And that's because here you're seeing that it's an object, which in Kotlin just means it's a singleton. There's only ever one instance of unit. And it literally does nothing. It has only the toString. You can print it out and nothing else. And so that does nothing useful thing, they take that really seriously. And you might be saying, okay, well, why do I care if something returns nothing versus something returns nothing useful? And the answer is that generics are cool and you want to use them. And so you might come into a case like this, which is building a result or error type. I don't know if you're into functional programming or something, but you might want to parameterize your result type and, parameterize some exception if it doesn't work. And you can easily do this with unit. It's just another type. It's a singleton object. This is fine. Now, in Java, this is not necessarily the case, as we can look at here. And you'll see that, one, we have to change from void. Like normally, people are probably used to this public void main. This is the code that we write all the time. But if you do something like this, it's not going to be happy with you. And you need to actually use this type, which again, if you look at it, it's just getting the type of the primitive. It's not too bad. You're changing one letter to capital, so like that's fine, I guess. But where it comes into play is a line like this, where you have some function that you're declaring in a very normal way, and you just want to be able to use it, but you can't. And neither version of this works. So if I go in and destroy my code first, you'll notice that this doesn't work because you obviously can't use void as a type, but this type also doesn't work because this void is wrong. And so if you really wanted to fix this, you'd have to actually have it return the type. But of course, this is not like, now this return, like you have to go in and actually do a return of this. It just becomes sort of messy. So is it a small difference? Yes, but it's useful. And it's one of the reasons that Kotlin is great. All right. I'm not covering platform types as much as I would love to, but since I just went over some generic stuff, it seems only fitting that I dive into those. And just because your eyes seem a little glazed over right now, I wrote you a little ditty which goes like A, B, C, D, E, F, G, T is a type param with upper bound any question mark. Woo-hoo. All right, yeah. I wrote that just for you. I'll be here all week, so don't worry. And what that means is that if you don't explicitly put an upper bound on your type, well, it's going to, in essence, be any question mark. And now you all are savvy Kotlin people. We just went over the type system. You know that question mark means nullability. And yes, it's true. If you do something like this, where you just say, hey, I have a generic T, everything has to be a safe access, and it's going to complain if you don't do that. So you better start putting question marks everywhere. Now, if you say, I only really want to use this generic in a non-null setting, well, you can easily do that, but you need to explicitly set the upper bound as any. You need to remember to do that. And now you'll see, this is fine, it's not complaining, it'll all compile. Okay. Another little low-hanging fruit of generics is this where clause. If you want to constrain some generic to more than one thing, you need to move it out of these angle brackets and into a where clause. So here I want a fuzzy animal, not just any animal. So T moves into this where clause and conforms to both animal and fuzzy.
I mean, fuzzy animals are the best. I don't see why you would ever not do that.
Exactly. This is why we're partners. And so that brings me to the big, scary, terrible topic that you've probably heard of but maybe don't understand, which is type erasure. If you do understand this, I'm sorry, but bear with me. So type erasure, it occurs in Kotlin just like it does in Java. There are reasons for that, aka performance, the bane of everyone's existence. And what it means for you as a developer is that you can't check types at runtime because, haha, they don't exist. So that's fun. And what that means in practice in code is that something like this will not work, and if you hover over it, it's going to say the type is erased, sorry, womp womp, play again next week. Now, you might say, okay, can I get any information, like list, anything? And the answer is yes, you can use star projections, and what a star projection is it means I know absolutely nothing about this type. Like, I literally don't care. Like, the class is list, and I have no idea what's in it. That's what a star projection means. And that's different from saying this is a list of any. Sometimes people mix those up. If you know that something is any, you actually have information about it, namely that it's not null, because it's not any question mark. And so this is very different. It means you absolutely have no information. And so now if you do something like this, your question is this a list of who knows what? And the answer might be yes, in which case you win. But I should mention that there's some foot gun action happening here, which is that you can really shoot yourself in the foot. Because type erasure happens, a cast like list as list int will always succeed at runtime. Why? Because normally this would fail if you try to cast something as the wrong type, but it has no idea what the type is, so it can't fail because it doesn't know it's wrong, and so it'll always succeed. And what that means for you as a developer is that downstream, you're going to get some mysterious error like, hey, this is not actually an int. It's going to fail downstream. It will not fail at this line. So be careful if you're using star projections and then feeling really confident about casting things, like you might want to think again. And indeed, you'll see unsafe. Okay, now we get to the relatable part. This is stuff that people should probably have seen, which is that you're feeling really good about your life, you're writing generics, like awesome devs out there, and it's all going swimmingly until you hover over here and IntelliJ says like, hey, this can have out type. And you're like, okay, like, I think that's fine, like, sure. And hey, like, it works, and there's no warning, so yay, we did it, developing. But of course, you have this class here, and it works, but it also worked here. And so if you're anything like me, you might have that moment where you're like, what the heck is this thing? And, well, I'm here to tell you. So here's an example. The only important thing to know about this example is that this function has t as an argument, this one has it as an output variable, and this one has it as both. So let's do a little experiment. If I put in here, you're going to see that those two output t's no longer compile. Okay, that seems fine. If I put out here, you're going to see that the two input t's that are being taken as arguments no longer compile. Like, all right, and then if you do nothing, everything compiles. So once again, in, the ones in the out position don't compile, out, the ones in the in position don't compile, or nothing, and you can use them anywhere you want. So you're like, all right, in, out keywords, got it, I understand it, something about positions, like, perfect. Except for you should probably also be wondering, like, why do you even care where t is used? Like, I don't know that made sense to me. And the answer is that in and out keywords are actually telling us something about the variance of a generic. And you might be asking, well, what is variance? And I'm so glad that this rapt audience asked that question, because I'm here to tell you the answer. So, variance tells you how two things that have the same base type but different t's relate to each other. So say you have foo A and foo B, it tells you how those two things relate to each other, but nothing about how A and B relate to each other. It's a different concept. So foo A relates to foo B, not A is some subclass of foo B, or of B, I should say. So, okay, you're like, variance, I don't know about this, so breathe. And now we'll dive in. So this fun code block is all of our definitions of variance. So welcome to the game. The first one, there are three of them, is invariance. And what that means is basically if you have A and B, and those things are different types, and foo A and foo B have no relation to each other, not a subtype relation, not a supertype relation, they're invariant. And what that looks like here that you can see visually is that you need an exact type match. So if you look at these definitions, just to kind of give you, one is the base class here, and then 2 extends 1 and 3 extends 2. So this is just my shortcut of doing a hierarchy. And it needs to be an exact match here. None of these super or subtypes matter. They won't work. Now, covariant means that subtyping is maintained. And so if A is a subtype of B, then foo A is a subtype of foo B. It's maintained. So that relationship stays the same. And what that looks like is something like this, where the invariant case still works, but this case now works too. And that's because 3 is a subtype of 2, so producer of 3 is now a subtype of producer of 2. So that's fun. And this one still fails. Womp womp. Okay, the last type of variance is contravariance. And what that means is that you actually flip that relationship. So whereas before it was A to B, foo A to foo B, this one is B to A, foo A to foo B. So we're switching those. And so to say that in words, if B is a subtype of A, then foo A is a subtype of foo B. And visually what that looks like is, again, this one always so boring, it always works. And then now you see that this first one is actually the supertype of 2, which makes it consumer 1 the subtype of consumer 2. So it's actually an opposite relationship between the A and B and the foo A and foo B. Okay, we made it through variance. So to go back and answer the question that I asked myself, which is kind of awkward, what does out mean? Well, out means that a generic is covariant and that its subtyping is maintained. Well, we can only do that if it's constrained to certain positions, and if you want to know more about that, there's books about it. And so ergo, out not only guarantees covariance, it also makes sure that you use it in the right position to fulfill that promise. Similarly, in means that something is contravariant, and in order to guarantee that something's contravariant, you can only use it in certain situations. So in tells you that the subtyping is inverted, and also where you can use it to guarantee that that works. So you're probably asking yourself right now, one, when is she going to stop speaking? And two, why do I care? The answer is soon, and you care because you use this every day in your life, even if you don't know it. Now, mutable list, if you look at this, it's invariant. It has no modification. It's not in, it's not out. And so what that means is that you have to give it an exact match on the type for this to compile. So here, string should in theory be a subtype of any, but obviously it won't work because I need to have this exact match. And now everything's happy. Now list, on the other hand, this is something that you would want to work. Like I should be able to put a list of strings into a list of any if I'm not going to modify it. And indeed you can, and the reason you can do that is because list has an out modifier on its generic. It's covariant. So the TLDR here is that variance gives you more flexibility while maintaining the same level of safety that you had. And one caveat on variance, it's here to protect you from other people, from consumers. It's not here to protect you from yourself. Like, that's a harder problem. And what that means in practice is that things like our arguments for constructors, they're neither in the in nor the out position. So here I've created something that has an in T, an out R, and then this invariant S. All three of these work in the constructor. Nothing is giving me a compilation error. Now, if I use it in a val, you can see that vals, they give you a getter, and so the thing in the in position will not work. And then vars, they have getters and setters, so both the in and out positions will fail. But if I copy and paste that code block and put private in front of all of those, everything works because the rules don't apply. So even though T is marked in and R is marked out, it doesn't matter. And this holds for functions too. All of these functions work no matter what variance I gave them because they're private. If I make them not private, we fail again. So this is just to illustrate that variance is for the public and consuming APIs. It is not for your internal work that is private to that class only. Okay, last topic from me before you get to move on to more practical stuff, use site versus declaration site variance. Again, these are buzzwords that people throw around a lot, but sometimes don't understand. So I just wanted to give a quick example, which is that here is something with a generic, and we have a function, and you can see that we're saying that there is a T, we're declaring it right here, and on this exact same line, we're saying that its variance is an out variance. Now, what would a use, this is declaration site because declaring and variance on the same line. What would use site declaration look like? Well, if I go ahead and remove this, the code is going to fail because you need an exact type match here. But I can go ahead and add the variance at the place where I use it. This is use site variance. This looks slightly different in Java. I have the code so I can put it up, but I don't want to waste your time with it now. But that's the difference. And the benefits, Kotlin does both of them, obviously. You can see it here. The benefits to this is if you do something at the declaration site, like so, if you had more functions than this, if you had 7 functions, it would apply to all of them. Whereas at use site, you would have to repeat this code often. Okay, you can still, as I just showed you, use site variance in Kotlin. Why would you want to do that? Because you can get projected types. So if we remove the variances here, you need the type match, it's going to fail. But say in this one case, I want to give it covariant status, I can do that inline. Same with contravariance, it'll fail without it. But if in this one case I want it to be contravariant, I can do that. And again, that's what we're getting with mutable list versus list. JetBrains just happen to already give you both the invariant and the covariant versions of those, and they're very helpful. We use them. But you can make your own if they're not shipped. So I'm now going to hand it over to Huyen, who can tell you how these things actually play out in your day-to-day life at a higher level.
So, okay, a little confession. Christina went through this very lovely kind of theoretical, almost existential discussion of anything, the meaning of any and nothing. And I'm going to talk about a couple things that are more concrete. And it might seem like we're kind of like doing 2 separate talks, but I promise there's actually a connection between the 2. So that's my excuse for now.
So, perfect. Oh, I got a microphone. This is dangerous. Okay.
I actually literally just figured out contravariance in the last like 10 minutes. Like I think I got it. Like I think I really got it. All right. So, oops. Let me go all the way up here. So I want to talk about a couple of particular language features, which we'll bring back around to kind of how everything ties together. But the first thing that I want to talk about is something that's kind of I absolutely loved when I figured out, and it's something that when I learned it just felt super Kotlin-y to me. And so hopefully y'all are familiar with lambdas. Well, I want to talk about this thing called lambdas with receivers. So here's an example of just some random code. Say I've got a recycler view in an activity, and I want to do a bunch of stuff to it. Maybe I'm loading data, and I want to do a set of things. Maybe the data didn't come back, so I want to do another set of things. So say I have a higher order function like this, right? So I have update some interface stuff. Higher order function, so it takes a lambda as a parameter. That lambda takes itself a recycler view as a parameter. And then in the body of the function, I'm executing that lambda, doing a bunch of stuff to my recycler view, and then maybe doing some other like UI cleanup stuff. Now below, I have the actual kind of lambda that I probably will be passing in. And again, single parameter recycler view returns unit, and then in the body, I'm kind of doing like really typical stuff, right? Recycler views that's setting the adapter, the layout manager, like adding a divider, cool stuff. Now, something like if you know like of the Kotlinites in your life that you love, you probably have heard them talk about like things like boilerplate and visual noise over and over and over again until it becomes audio noise in your ears. But there's actually a lot of good things that you can do with Kotlin to make certain things easier on yourself, on your eyeballs, and reading code. And if we look at this lambda here, you can see that, okay, well, this is pretty typical, easy, straightforward stuff, but just look at this. I'm calling recyclerview.this, recyclerview.that, recyclerview. Is there anything that I can do to make this more readable and just make this a little bit easier myself to code? Well, there is. So what I can do is I can change that lambda to a lambda with the receiver. So what's a receiver? So when you have a lambda, you have some parameters. And when you have a lambda with a receiver, what you're essentially doing is taking one of those parameters and elevating it. You're kind of giving it some superpowers. And the superpowers that you're bestowing upon it is the ability to call methods on that object without actually qualifying it, without actually having to like kind of reference that object. So here, if I want to turn my lambda down here into a lambda with a receiver, you can almost think about it as if I'm kind of taking these recycler view dots and, I'm in Vim. What do? There we go. And it's almost like I'm taking the recycler view dot away from those method calls and taking it out of the parameter list. And instead taking that recycler view dot and putting it in front of that parameter list, in front of those parentheses. And I can do the same thing up here. So what I've done here is that by specifying a type and then putting that dot before the parameter list, is I'm basically saying, hey, I have a receiver in this lambda, and that receiver is a recycler view. And as you can see down in my lambda here again, rather than having to call that recycler view dot whatever like 3 times, I can just directly call those methods because within the body of that lambda, there's an implicit reference to that receiver. And when I'm actually executing this lambda, you can see like the lambda call looks kind of the same. But there's something else cool about lambdas with receivers where you can actually call it with this syntax. So I can just call that lambda directly on the receiver object. And it almost kind of looks like I snuck on an extra method onto that recycler view, which is kind of neat. Now, the type that's in front of the parentheses here, the receiver type, well, with the type, it can be, in fact, nullable if you want. So what's really neat is that when you make an object the receiver of a lambda, it essentially becomes this inside of the lambda body. So if I have this where I have a nullable type, say for some reason maybe my recycler view isn't there, maybe it's in a view stub or something, I can actually do a null check on this, and I can even maybe return, actually, I have to, if I want to return from a lambda, I have to actually give it a label, and I could even like kind of short circuit it if for some reason my this is null for some reason. So again, something to be aware of, you can have nullable receiver types. So this actually came up during dinner yesterday, but while you can do this, it's not always the best thing to do. As you can see here, like in this call here, I don't really have a notion of any kind of like specific null handling. It could be possible that I'm swallowing errors when I'm writing functions like this. So while you should be aware of it and you can use it, use with caution. So kind of going back to how I actually call this lambda, as we kind of like talked about, it almost looks like I stuck a new function onto recycler view, but there's actually a much more kind of official kind of like Kotlin way of doing this, and that's with extension functions. So if you haven't read Kotlin in Action, which you totally should, it's an amazing book, they do this really cool comparison. They say that lambdas are to lambdas with receivers as functions are to extension functions. And the reason that is that we get this kind of nice idea of a receiver. So here's a quick example. Say you're writing an app and you're getting some JSON back from your server folks. And for some reason, they decide sometimes that you might get null JSON or you might get an empty JSON object. I don't know why, sometimes talking to server people, you never know. But say you have to handle this thing, all right? You might have null JSON, you might have this empty object, and you want to be able to check for that and handle it some way. So you might write a function like this, is null or empty object. I check if the JSON's null or if it's equal to empty object, and I know I could probably do something more like this, but either way, I write a function, check for these things, and at some point later when I'm ready to handle and process my JSON, I call it. So this works. This is, nothing new. But, I'm kind of thinking about all those really cool, Kotlin methods, like is null or empty or, is blank or whatever, where the syntax is again, kind of like we're calling it on that string. It's almost like it's part of that string's methods. Can I do something like this? Can I make my syntax a little bit better? And indeed you can with extension functions. And again, it's actually playing with this idea of receiver, basically. Like there's an object in your function that has this implicit reference. So you can go ahead and call stuff on it without having to actually, name that reference. So if I do something like this, so a function, and I'm going to be extending string. In fact, I'm going to be extending a nullable string. Oh, I kind of already knew what I wanted to call it. I'm going to give it my function name, parentheses, and actually, function body, and again, because we're using receivers, we can refer to this receiver as this. So I'm going to do a null check on this, or this equals some kind of empty object, and there we go. So I have an extension function, and the nice thing is I can call it like this. So now through the use of extension functions, we've added our own kind of new, awesome, sexy, syntactically sexy utility methods. And this is a really good use case, like when we're writing our apps, we tend to have a lot of utility methods, right? We have things that we do over and over again. We want to be good coders and kind of pull that code out so we don't repeat ourselves. And so we write like string utils and array utils and all that other kind of stuff. And while they're handy, the syntax is not always very nice. But with Kotlin, we get this really nice syntactic sugar where we can call it again. And it's like we're adding functionality to this object without A, inheritance, or B, actually having to change the object. Now, you might be asking yourself, am I actually changing or extending the class? Well, you aren't. So if we look at the bytecode that this generates, where is it? Oh, no. Okay. If you were to look at the bytecode that it generates, it actually looks very much like my first method here, where rather than having kind of a method on here, it's basically just the same method that takes the one parameter, and then the Kotlin does the magic of making it look like an extension function. So actually, we're running out of time, so I'm going to start blitzing you a little bit, so I apologize. So lambdas with receivers, extension methods, they look like really nice syntactic sugar, but can you actually do something more with them? And the answer is absolutely yes. So there's this pattern that I just kind of learned the name of very, very recently from called execute around method, and it's in this talk by Venkat Subramaniam, which you all should totally watch. It's an amazing talk, but he talks about different ways to use lambdas. And the pattern that I really adored out of that talk is something called execute around method. So execute around method is this pattern that you use when you say you have like a pair of things that have to happen when you have to do something in the middle. So think about opening a file, right? And reading something from a file. You have to open the file, do your thing, close it. An example that comes up a lot is like database transactions, because you have to begin the transaction, you actually do the stuff that you want to do, and then you have to end the transaction. So it's a lot of like what Venkat calls ceremony, right? It's a bunch of stuff that we have to do, but it's not the focus of what we want to do. And what we can do by using these like language tools like lambdas with receivers and extension methods is actually take the ceremony out of it. We can write methods that allow us to think less about the ceremony and more about the actual task that we're trying to do. So Here's an example. If you've worked with views much and you know that, we've got this really great system of styles and attributes and resources in Android, but every now and again, you can't rely on the view to take stuff out for you. You have to start pulling drawables and colors out yourself. And it looks something like this, where we have this obtain styled attributes that you call in the activity. You pass it a style ID, you pass it a stylable ID, and stylables are just basically int arrays that have more IDs in them that let you know what you want to bring out. And then you get this typed array thing. And as soon as you type obtain styled attributes and get that typed array, Lin's going to be like, yo, you have to recycle that. Like, before you even take a breath, it tells you that. And that's, again, kind of like this notion of these other things that you have to do, right? We have to get a typed array, and at some point after you've done all your business on it, you have to recycle it. And again, if you look at this code here, it's not that hard. It's kind of like stuff that we're used to seeing, but we can actually make it a little bit better, and not just better, but safer. We can kind of take the burden off of ourselves to remember the ceremony and put it on another method. So say I actually created a method, something like this. So I can use the lambdas with receivers syntax and make this and create a method that helps me with the ceremony, that alleviates me of this ceremony. So here in this higher order method, I have 3 parameters: a style resource ID, a stylable resource ID, and a lambda with receiver. And what I'm doing here is, again, so the first thing I need to do is I'm obtaining the style attributes. And rather than actually doing all that attribute pulling or whatever myself, I'm letting the person that's going to be using my function define that behavior, define the task that they need to do inside of that block. And then I'm just going to call the block. And then it's my job, basically, to recycle it. And then when I actually call it, it'll look something like this. So again, it seems like just syntactic sugar, but it is a way for you to write not only cleaner code, because now I can erase the kind of references to the array, but also I can trust, hopefully, that I have, properly gotten the typed array and recycle it. And you can use this kind of everywhere you have this kind of bookending kind of work that you have to do. All right. 2 minutes left. Domain-specific languages. This is kind of something that pops up a lot when you talk about lambdas with receivers and extension functions. And if you don't know, a domain-specific language is basically a small language. It's a specialized language for a specific problem space. You have DSLs like SQL, which is its own language, and you have things that we're very familiar with, Gradle, where it's basically being able to define or use an API, define a task, but do it in a declarative way, do it in a more readable way. So again, Gradle, it's build automation, but you do it in a very structured way. And with Kotlin, using all of these kind of interesting tools, we can do that. So here's a quick example. If any of you have used constraint layout, I absolutely adore it. And there's this thing in it called constraint set, which allows you to actually create those constraints programmatically, and it's got a really beautiful, fully featured API, but when you start doing things like changing layouts, it starts looking like this. There's a whole laundry list of method calls, and you kind of start to lose what's going on, right? There's lots of visual noise. I'm calling constraint set who knows how many times. I've got IDs view IDs being used all over the place. Is there something that we can do to make this better? And in fact, there is, and I'm going to skip right to the final example. You can actually write a DSL for this. And using lambdas with receivers, using extension functions, you can hide the ceremony. You can take away, you can turn these laundry list of API methods and turn it into something much more readable, much more consumable. And if you kind of squint at what's on the screen, it almost kind of vaguely looks like XML tags and a layout. And I just think it goes to show the power of it. I mean, really all we're doing is using lambdas with receivers, right? I have an update function here. The outer block is really just one lambda with receiver, and then I'm actually just nesting them to create these kind of little structures. And I'm taking these API calls and just giving them structure, making them more declarative, making them more readable, and bringing kind of more understandability and maintainability to it. So what's the point of all this? Okay, we talked about the type system, we talked about lambdas with receivers, and I think what's interesting is that you might not ever write a DSL in Kotlin. It's not really a day one thing, but I think it's a good example of the tools that Kotlin gives us, between the wonderful type system, between the way that generics work, between having language features like lambdas with receivers and extensions. You can do amazing things. You can make your code more readable, and you can not just use the standard lib, which, by the way, if you look at kind of some of your favorite standard lib methods like apply and run and let, and I would actually encourage you to look at them, you can see that they're chock full of generics, and they're got inline and lambdas with receiver and extension methods. And it just goes to show you, I think what we're trying to get at is that looking at the foundational things, looking at the language features, as you're going on this road to Kotlintown, referencing the talk, roll credits, you need an understanding of both. And that way that'll allow you to really take advantage, to really leverage what Kotlin can do and do some really interesting things. And that's our time. Thank you so much.
Thank you.
Find us for questions.